Managing hazardous waste is a straightforward process: generation, accumulation, transport, and disposal. At each step in the process, there are well-defined practices and procedures to follow to comply with hazardous waste regulations. But there is more to responsible hazardous waste management than just following the standard management procedures. Remember, the ultimate goal for labs, and in fact for all generators, is to reduce the total environmental impact of hazardous wastes to the very lowest level possible. It's an ambitious target, requiring a commitment of time and resources, but the payback is environmental quality, and it's well worth the effort. To fully realize minimum environmental impact, an organization must confront two special challenges. One is emergency preparedness, constant readiness to respond quickly and effectively to accidents, spills, or leaks that threaten the environment. The other is waste minimization, an ongoing effort to reduce the amount and toxicity of all hazardous waste generated at the lab. Even at the best-run lab, with the most conscientious employees, accidents can happen. An accident in a lab or research facility could involve a staggering array of hazardous materials and hazardous waste that could inflict serious damage to the environment. For human safety and environmental protection, every facility must be fully prepared to deal with any emergency that could involve hazardous waste. Since many types of emergencies can threaten to spread hazardous wastes, the regulations require every facility to have plans and preparations for dealing with these emergencies quickly and effectively. For many labs, the emergency response procedures for the chemicals and other hazardous substances in the lab are specified in the Chemical Hygiene Plan. Your facility may also have a contingency plan that specifically addresses emergencies that involve or threaten hazardous wastes. Everyone in the lab should be able to recognize when an accident or release is hazardous. Thereafter, your role in the response depends on the severity of the incident. Most accidents in the lab involve small volumes of materials. A vial is knocked over or a beaker breaks on the lab bench. Small-scale spills are called incidental spills if they do not pose a significant threat to the health or safety of lab personnel. For small-scale spills, lab personnel will often perform the cleanup. The Chemical Hygiene Plan will usually describe the proper small-scale cleanup procedures and identify the amount that personnel can clean up. Typically, spills of less than about 1 liter of most common lab chemicals may be cleaned up as small-scale spills, but you should check your CHP for details on specific chemicals. In any spill event, the wastes resulting from the cleanup may be hazardous waste. Make sure to handle and dispose of the waste properly in a designated and labeled container. Every facility should have equipment dedicated for spill response. Brooms, squeegees, and buckets are generally included in a small cleanup kit. A cleanup kit should also have a variety of absorbents and neutralizers. You may also have a salvage drum for containing leaking laboratory containers. The kit may also contain special personal protective equipment. You should know the exact location of each spill cart or locker in the vicinity of your lab, and how to use the equipment safely and effectively. In the course of lab activities, anyone could become involved in an emergency. You could discover a leaking hazardous waste drum that might be an environmental or safety threat. Every lab worker should know the proper steps to take in an emergency. The first step is to notify the responsible authority. You need to know who to contact.
Hello, this is Linda.
Your facility has designated an individual, titled Emergency Coordinator or something similar, who should be notified whenever an emergency occurs.
There's a leak in the hazardous waste drum.
Where?
He or she is trained and responsible for taking charge of emergency response actions.
Methylene chloride and sodium sulfate.
At least one emergency coordinator is either on duty or on call at all times. Contacting the coordinator or the communications center quickly with a clear, comprehensive report of the incident will speed the overall response and reduce the risks to people and the environment. Some larger-scale emergencies may require lab evacuation. You should be thoroughly familiar with all designated evacuation procedures. You should know how to get out of your work area quickly and the location of your headcount area. For larger-scale emergencies, most facilities have a designated team that is trained and equipped to respond to hazardous material spills or emergencies. This team will deal with emergencies that pose a significant threat to human health or the environment, such as a large-scale spill, fire, or explosion. Waste minimization simply means adopting and practicing operating procedures that minimize the amount or toxicity of wastes generated. Minimizing hazardous waste protects the environment and reduces the time-consuming tasks associated with waste management and the often heavy expenses of treatment or disposal. There are 6 broad categories of waste minimization practices. They are waste separation and segregation, material recycling and reuse, good housekeeping, material substitution, process modification, and inventory and purchasing controls. Using these techniques, your scientific expertise can go a long way towards minimizing the impact of your lab's operations on the environment. Keep all hazardous waste separate from all other wastes and materials. Mixing a hazardous laboratory waste with other materials can result in the entire mixture becoming a hazardous waste. Segregate individual waste streams as much as possible. For example, halogenated and non-halogenated solvents should be accumulated separately. Solvents that have been segregated can often be reused or recycled easily, but mixed solvents often cannot, and waste solvents can account for up to 75% of the hazardous waste generated in some labs. In-lab recycling should be practiced whenever possible. Mixtures of used alcohols can sometimes be reused in preparing standard solutions. Used nitric or hydrochloric acid from ion exchange column cleaning can often be used as a pre-cleaning rinse on another column. Possibly the simplest and most obvious way to minimize waste is by practicing simple good housekeeping. Avoid spilling or dripping any hazardous substances or chemicals. Even spills of some common lab chemicals like methylene chloride can become hazardous wastes. Test tube stands can help avoid spills and breakage. Use unbreakable containers like plastic or plastic-coated bottles whenever possible. When transporting chemicals from receiving, leave them in the sturdy protective shipping containers until they reach their destination. Use secondary containment devices for lab procedures to contain spills or drips before they can spread. Always label and note the contents of any waste or material that you generate and save. 6 months or 6 years later, it is unlikely that you or anybody else would know what's in an unlabeled bottle. Substitution is another good method of waste minimization. Substituting non-hazardous reagents, catalysts or solvents, for hazardous ones. For example, acid cleaning solutions can often be replaced with non-hazardous detergents or with ultrasonic cleaning. Some commonly used but toxic lab chemicals can be replaced with less hazardous ones. Alcohols can sometimes be substituted for benzene. Also cyclohexane for carbon tetrachloride, and sodium hypochlorite for sodium chromate. For a process that requires hazardous materials, try to use the minimum amounts necessary. Use hazardous solvents and cleaners sparingly, and save lightly contaminated solvents for later use in non-critical applications. Choose instrument analyses or physical test methods over wet chemistry whenever possible. Instrument and physical analyses usually generate very little waste. Scaling down the magnitude of procedures and experiments offers enormous potential for waste minimization. Careful planning is required, and often more sensitive analytical instruments must be used, but these techniques save on raw materials and on waste disposal costs. Some researchers are running microscale procedures that use as little as 25 milligrams of solid or 100 microliters of liquid reagents. Controlling inventory of reagents and chemicals can help reduce hazardous waste generated from old, deteriorated, or expired chemicals. Try to avoid over-ordering of reagents, supplies, and materials, especially those with short shelf lives. Supplies that have exceeded their shelf life will have to be discarded and may be hazardous wastes. By limiting order quantities to the amount you know will be used within a reasonable period, you avoid generating a hazardous waste through material expiration. When stocking supplies, make sure that all materials are clearly labeled, including the CAS number, and dated with the received date. Use older materials first to avoid expiration. Lab personnel should share chemicals and stocks to the maximum extent possible. If you need a new reagent or standard solution, first check if it is available in the stockroom or from another lab. When you do have to place an order with a supplier, order only the amount that is immediately needed. On average, most labs waste about 35% of the materials they purchase due to product expiration. Whenever possible, order from vendors that will take back excess, unused materials. Even the most closely controlled inventory procedures cannot completely screen out all materials that will eventually become wastes. Periodic lab cleanouts are needed to get rid of excess, expired, or unwanted supplies. The lab should have a written procedure and schedule for cleanouts. The chemical hygiene plan will usually describe these procedures. And most importantly, after each cleanout, someone should assess the results. What material showed up most? What was the reason each material was disposed of? And how can the volume of waste material be reduced? The EPA, state environmental agencies, the American Chemical Society, the National Research Council, and others offer excellent manuals on waste minimization opportunities in labs. If in the course of your job you apply your scientific skills and analyze the procedures you perform, you can surely find new, creative ways to minimize hazardous waste in your lab. As we succeed in hazardous waste minimization, the waste management burden decreases. The whole lab runs more efficiently. Time and money are saved, and the likelihood of emergencies goes down. Our jobs get easier, and the real bottom line winner is the environment.